Ship 36 exploded yesterday. Test pad destroyed. Any normal space company would shut down for months. SpaceX, they're already planning the next launch. Here's what shocked NASA. SpaceX has blown up 9 rockets since 2023. Yet they just won the $2.9 billion moon contract. While competitors spend years perfecting one rocket, SpaceX destroys them and somehow wins every major space deal. Their launches cost $70 million. Competitors, hundreds of millions. So why does blowing up rockets make SpaceX more successful than companies that never fail? Let's dive right in. The explosive revolution. Picture this. June 18th, 2025, Starbase, Texas. Ship 36. Towers on the test stand. All systems green. 6 Raptor engines ready to fire. Cryogenic fuel flows into the massive tanks below. Everything looks perfect. Then, catastrophe strikes. The explosion rips through the morning air like thunder. Flames shoot skyward. Smoke billows across the facility. Within seconds, a $100 million rocket becomes twisted metal and debris. The test pad? Completely destroyed. The plumbing system? Mangled beyond recognition. Even SpaceX engineers admit it's a total loss. But here's where the story takes an incredible turn. Instead of panic, SpaceX engineers are already analyzing the data. Instead of shutdowns, they're planning the next test. Instead of fear, there's excitement. Most companies would fire half their staff after losing a rocket this spectacularly. SpaceX, they call it rapid unscheduled disassembly and treat it like Christmas morning. Why would anyone celebrate destruction? The answer will blow your mind. The hidden killer. Deep inside Ship 36's payload bay sat a small tank most people never heard of. A nitrogen composite overwrap pressure vessel. Engineers call it a COPV. This tank holds high-pressure gas that keeps the rocket's systems alive during flight. It's like the rocket's heart. When it stops beating, everything dies. The investigation revealed something terrifying. The COPV failed before reaching its design pressure. It simply gave up. But wait, this sounds familiar. 2015, a COPV failure destroys a Falcon 9 rocket on the launch pad. 2016, another COPV failure destroys a Falcon 9 during flight. Now, 2025, COPV failure destroys Ship 36. 3 catastrophic failures, same root cause. Any rational company would abandon this technology completely. SpaceX doubled down on it instead. The reason why will change everything you think about innovation. NASA's impossible choice. While SpaceX rockets explode in Texas, NASA administrators pace the halls in Washington. Their Artemis program hangs in the balance. American astronauts are supposed to walk on the moon again by 2027. But how can you trust a company that blows up rockets to safely land humans on another world? Here's the shocking truth NASA discovered. SpaceX's explosions aren't accidents, they're education. Flight 1 lasted 4 minutes before self-destructing. Engineers learned exactly how the rocket fails under stress. Flight 2 lasted 8 minutes. Double the data, double the knowledge. By Flight 4, both the booster and spacecraft completed their full missions. By Flight 5, they achieved something impossible, catching a 250-foot rocket with mechanical arms as it fell from space. Each explosion taught them more than years of computer simulations. Meanwhile, ULA's Atlas V rocket has a near-perfect success rate. It rarely fails because it rarely pushes boundaries. Safe, reliable, expensive, and slow. ULA takes 5 years to develop what SpaceX develops in 5 months. Perfect safety comes at the cost of progress. So NASA faces an impossible choice. Stick with the safe option that moves like molasses, or bet America's space future on a company that treats explosions like learning opportunities. The stakes couldn't be higher. The $70 million secret. Every SpaceX explosion costs millions in hardware. So how do they stay profitable while literally burning money? The answer lies in one number, 70 million. That's what a Falcon 9 launch cost customers. Compare that to ULA's launches, often over $200 million for the same job. How is this possible? SpaceX reuses their rockets. ULA throws theirs away after one flight. But reusability only works if you understand exactly how rockets break. And the only way to learn that is to break them. Repeatedly, spectacularly, intentionally. Every explosion teaches SpaceX how to build stronger rockets. Every failure shows them what to fix. Every disaster becomes data for the next design. While competitors spend years in meetings avoiding risks, SpaceX finds risks and conquers them. The math is brutal. SpaceX can afford to lose 10 rockets and still launch cheaper than anyone else. But the real advantage isn't cost, it's speed. The learning machine. April 20th, 2023. Flight 1 lifts off from Starbase. 4 minutes later, it's tumbling through the sky. The flight termination system activates. The rocket explodes in a brilliant fireball. Most companies would spend 2 years investigating. SpaceX spent 7 months and launched again. November 18th, 2023. Flight 2 reaches space before breaking apart during re-entry. March 14th, 2024. Flight 3 completes propellant transfer tests in space before losing both stages. Number 26, 2024. Flight 4 changes everything. Both the booster and spacecraft complete their missions. The booster splashes down softly in the Gulf of Mexico. The spacecraft survives re-entry and lands in the Indian Ocean. From total failure to complete success in just 14 months. But here's the part that shocked the entire industry. SpaceX wasn't just tolerating these failures, they were designing them into their process. They push hardware past its limits on purpose. They want to see where things break. Because once you know exactly where something fails, you know exactly how to make it stronger. Traditional rocket companies test components individually for years. SpaceX tests entire systems together and watches them fail in real time. The data from one explosion teaches them more than 1,000 simulations. The Regulatory Loophole. When Ship 36 exploded, everyone expected the FAA to shut down SpaceX immediately. After all, they regulate everything that flies in American airspace. But here's the twist that changed everything. Ground testing isn't regulated by the FAA. When rockets explode on the test stand, SpaceX investigates themselves. No government oversight, no months of paperwork, no bureaucratic delays. This regulatory freedom is why SpaceX can test every week, while competitors test every year. The FAA only steps in for actual flights or if debris threatens public safety. Ground explosions? SpaceX handles those internally. But this freedom comes with a price. When things go wrong, they go very wrong, very publicly. Every explosion makes headlines. Every failure feeds the critics. Every setback becomes ammunition for competitors. The question that haunts the industry, does the benefit outweigh the risk? The competition crumbles. ULA executives watch SpaceX with growing alarm. Their methodical approach produces ultra-reliable rockets, but reliability doesn't win contracts anymore. Speed wins contracts. Cost wins contracts. Frequency wins contracts. The commercial space market has changed. Customers don't want perfect rockets in 5 years. They want good enough rockets in 5 months. SpaceX delivers both speed and cost savings, even if some rockets explode along the way. ULA's new Vulcan rocket represents their attempt to compete. It's more advanced than anything they built before. It's also more expensive and launches less frequently than Falcon 9. The writing is on the wall. Adapt to the new reality or become irrelevant. Other competitors are already falling behind. Blue Origin's New Glenn rocket has been almost ready for years. Virgin Orbit went bankrupt. Rocket Lab struggles to scale up. SpaceX's explosion strategy isn't just working, it's destroying the competition. The human cost. But SpaceX's strategy has limits that nobody talks about. Ship 36's explosion didn't just destroy hardware. It pushed Flight 10 back at least 2 months. The test site needs complete reconstruction. Every explosion, no matter how educational, costs precious time. Time NASA doesn't have. The Artemis program depends on Starship working flawlessly by 2027. If SpaceX can't control their explosion rate, American astronauts might not return to the moon for another decade. China's space program doesn't explode rockets for fun. They methodically advance toward their own lunar landing. While SpaceX learns from failures, China learns from successes. The Government Accountability Office warned about this in 2023. They predicted SpaceX's development delays could derail America's entire moon program. Were they right? The answer is coming sooner than anyone expected. The moment of reckoning. As Ship 36's wreckage cooled in the Texas heat, something remarkable happened. No panic meetings, no executive firings, no program delays. Instead, SpaceX immediately began preparing Ship 37. The hot staging ring was removed from Booster 16 and sent back to the factory for upgrades based on Ship 36's destruction. This response reveals SpaceX's true genius. They don't just accept failure, they weaponize it. Every explosion becomes data, every disaster becomes a design improvement, every setback becomes setup for breakthrough. But the ultimate test is coming. Flight 10 will prove whether SpaceX's explosive strategy can deliver on their biggest promise: landing humans safely on the moon. 9 previous flights have blown up spectacularly. Will Flight 10 be different? Can a company that destroys rockets actually be trusted with human lives? The answer will determine not just SpaceX's future, but America's dominance in space. Because if explosions really do win over safety, then everything we thought we knew about rocket science is wrong. And NASA is betting everything on that possibility. The Space Corps conclusion. So here's what we've uncovered. SpaceX doesn't just tolerate explosions. They've turned destruction into their greatest weapon. While competitors hide from failure, SpaceX hunts it down and learns from it. 9 rockets destroyed, billions in hardware lost, but also 9 giant leaps toward making space travel routine. The crazy part? This strategy is already reshaping entire industries beyond space. Tech companies now fail fast to innovate faster. Automakers crash test constantly to build safer cars. Even NASA is adopting SpaceX's approach. But here's the question that keeps me up at night. What happens when SpaceX finally perfects this process? When they stop needing explosions to learn? Will they still be the innovative force driving humanity to Mars? Or will they become just another slow, careful corporation? And more importantly, what other impossible problems could we solve if we stopped fearing failure and started embracing it? Drop your thoughts below. Are you Team SpaceX's chaos or Team ULA's caution? And what industry do you think needs this explosive approach next? The future of space exploration hangs in the balance. Stay curious, Space Corps family. Ship 36 just exploded during ground testing, and Flight 10 is officially delayed. June 18th. What should have been a routine engine test turned into SpaceX's $200 million disaster. The explosion was so violent, it destroyed the entire test stand and lit up the Texas sky. But here's the shocking part. Elon revealed the component that failed. Broke below its safety limits. This wasn't overpressure or human error, something that was designed to never fail, just failed. Why is this the third Block 2 Starship to catastrophically fail? Is there a fundamental flaw in SpaceX's Mars rocket design? And what does this mean for the future of space exploration? Stay tuned because what we found will change everything. Let's dive right in. The night everything went wrong. So what exactly happened on that fateful night? Let me walk you through the timeline that changed everything. June 18th, 11:47 p.m., Ship 36 was sitting at the test stand, looking peaceful, almost majestic against the Texas sky. The engineering team had just finished their standard procedure, loading liquid oxygen into the bottom tank, methane into the upper section. This was supposed to be routine. SpaceX had done this exact test hundreds of times before. 6 engines would fire for a few seconds. Data would be collected and Flight 10 would be one step closer to launch. But routine became catastrophic in ways no one saw coming. High-speed cameras were rolling, capturing what should have been another successful milestone. Instead, they recorded the exact moment disaster struck. Dense white clouds suddenly erupted around Ship 36's nose cone. Not the normal venting you see during tests. This was different, violent, wrong. All what we work out of that time. The footage shows something that still gives engineers nightmares. The rocket's skin began tearing apart, all like a zipper opening from top to bottom. 400 feet of precision engineering, CAC hacks unraveling in real time. But what you're about to learn next in CAC hacks will change how you think about rocket safety forever. When physics becomes your enemy, the destruction happens so fast